Hey everybody, welcome to Talking Precision Medicine. Today we're doing something that we haven't done before in this podcast, and that's having a previous guest back for an update. Last October, we ran a conversation with my colleague David Mittelman, who's the founder and CEO of Othram, which is a forensic genetics company based out of Houston, Texas. David is pioneering the use of whole genome sequencing to solve cold cases and to deliver justice or comfort to the families of victims. They've been in the news a lot. At the end of 2019, they were featured in solving quite an old cold case, possibly the oldest cold case ever solved with forensic DNA. And David's also been in the news recently discussing current trends we see in consumer DNA testing. This is sort of 23andMe and Ancestry kind of genealogy-driven platforms, which is something he knows a lot about. So we felt it was time just to get David back on the phone and talk to him about what's going on at Othram and to give him an opportunity to describe their new database, their product called DNA Solves. That's DNAsolves.com. Anyway, I'm going to let you hear it from David, not from me, but I'm super excited to have episode 2 of what's essentially Talking Precision Medicine's cold case files. Thanks very much, and enjoy the show. So, David, tell me a bit about DNA Solves. This looks like it's a new product that Othram has launched.
Yeah, so we launched DNA Solves at the end of 2019, and it's a database very similar to GEDmatch, to other genealogical databases. But this database is not for genealogy or for medical research, or really for anything other than helping law enforcement. So it's an opportunity to contribute your profiles and information from other testing companies that you might have tested at, whether 23andMe or Ancestry or multitude of other testing companies. And what it allows you to do is to take those files, put them into a database. Again, the only use is for law enforcement. It's not publicly available to individuals, but law enforcement can use it to match against a case that they're running if they're trying to solve a human ID, problem for unidentified remains or an active criminal investigation.
That's cool. And so who are the consumers of the database then? So this is a database that crime fighters or law enforcement would directly use, or would they engage Othram to kind of help navigate the database?
So we don't have a public-facing search, and I think that's actually an advantage. There's been a lot of unrest about the risks and liabilities in allowing public search. There's folks that have particularly demonstrated what's possible if you do public search at GEDmatch and then scrape the information and perhaps upload profiles that are not genuine and use that to somehow scrape information about other folks that are in the database. So that's all a lot of complexity that we didn't want to deal with. And so one of the key features of DNA Solves is that when you put information in, you cannot get back any information other than information about your particular data. And so there's no public search. So if law enforcement were to come to DNA Solves, they'd be able to submit data for a case that they're working on. Then, we'd want to validate their credentials, and we would then return back to them results. So there's not like a self-service public searching kind of mechanism to it.
Well, no, that makes sense. After all, this isn't, as you said, this is not for genealogy. This is serious business.
I also don't want to trick anyone. So there's two models that you're probably aware with for consent. One model is opt-in. That's what GEDmatch uses, and you can elect. You're by default not included, but you can elect to opt in and allow law enforcement to use your data. The other model is opt-out, and that's what Family Tree DNA uses for their database. And so there, you're automatically included in search unless you specifically and actively opt out of being searched. I think both those models are fine, but the DNA Solves model is a little different. We don't do anything but this one thing. So you can't even match against relatives. We don't return, information. So it's a more streamlined and easier way to consent someone, because you don't have to risk that they're coming for one purpose and they're confused, and you've kind of incentivized them to do one thing, but you're going to use the data differently. Like the only thing you can do on our site is contribute data to help solve a crime. So it's a straightforward consent, but it's also a more secure way to do things, since you can't access anyone's data but your own.
Let's lift the hood a bit and look underneath. So a database is only going to be as useful as the metadata. Tell me a bit about how you're curating the genetic data that goes into this database.
So there's two pieces to metadata. There's the data that the people are contributing inward, and that's going to be the genetic information. And that information we run through a pipeline that we have that'll essentially record all the observed positions. We accept a lot more than just array data. So we'll do array data. We also accept sequencing data. A growing number of customers have tested at companies that offer full genome sequence. So it's actually an interesting data problem to integrate variant calls from diverse sources to normalize and standardize that so they can be compared against each other. And then, of course, to understand how to match. The matching algorithm is going to be very different here because you can't make the assumption like you do at a testing company that all the markers are always there for all the samples that you're matching against. So there's definitely an element of standardization, post-processing on that data so you could have apples to apples comparisons. The other thing that we do on the metadata, though, people are voluntarily allowed to submit their name and their parents' name, for example, and date of birth for all those folks. And what that does is it creates a little bit of an anchor point if that was to be used in an investigation to identify someone. It's easier to kind of place that data point on a tree.
Interesting. Yeah. So just to kind of say that back to the audience, what's so fascinating about this is DNA Solves is running into a lot of the same kinds of challenges you'd see using genomics in the clinical setting, which is there are different platforms. So you have to harmonize across, data generation platforms. And then beyond that, you need to have some sort of robust way of making sure the variant calls are reliable. I'd be curious to see if you ever get something like this. Would be neat to have like families come in and actually submit, say, trio data. I don't, that's something you see in rare disease. I wonder if you'd ever get kind of a family of wannabe crime helpers or, crime solving helpers where you could really get sort of heredity patterns.
I agree. I think that would be, that'd be clever. I will tell you what we have had is we've had folks that are, hobbyist genealogists that have sent us information, and many of them are pretty excited about what we're doing. What they've done is they've sent us information along with known relationships. So not necessarily a trio, but kind of like what you're saying, established pedigree, and then with lots of data points. And that's been really valuable as well, because we can use that sort of data to kind of train how we compare samples. And interestingly enough, a lot of these folks have data points from many different sources. So maybe one person in the family tested at 23andMe, another one got a full genome sequence from somewhere. So it's definitely an interesting puzzle. And it does mirror the clinical space in that, if you're doing clinical variant interpretation, for example, you want to make sure you standardize how those variant calls are made. It reminds me of the problem, obviously on a much larger scale, that Nomad has over at Broad, right, where they're curating a giant variant database, and they probably have a lot of heterogeneity in the data that's coming in.
No, that's undoubtedly a challenge. But for those who aren't familiar with David's background, I do encourage you to listen to the previous longer interview. He was on the ground floor of a lot of the sort of adoption of whole exome, whole genome, and moving that towards the clinic after the Human Genome Project. So I'm confident that you and your team are going to be able to crack this, but the platform issue is challenging. The other problem that you mentioned is kind of the sparsity of data, right? So you'll have variants in some and from other samples, you'll just have kind of empty space in the matrix. Are you working on any kind of tech specifically to deal with that? Are you adopting solutions from the clinical space?
Well, I mean, the nice thing about Ancestry, in the clinical space, you really need to observe the variant that you're particularly interested in, because there's going to be a clinical relationship with that one variant. In the Ancestry space, you have a little more leeway. So it's less important if you've accessed direct observation of any one specific marker, and more important that you've kind of, to some extent, uniformly covered the genome with markers in general, so that you can kind of infer whether or not the two sequences are similar or not similar. And from there, kind of derive an idea of how related two people are. So you still need to have overlap, because it makes it really hard to estimate difference. If wherever there's one call and the other place there's no data, that's kind of hard to match up and sensitively detect a relationship. But you have a little more flexibility, because you're not looking for any one specific marker.
No, that makes a lot of sense. I hadn't thought about that, but a very good point. I want to talk to you a little bit about DNA Solves in the news. So there was a story, I guess, just at the end of last year and then early this year around an infamous case that was identified. Tell us a bit more about your foray into the Buffalo Cave.
So that's an interesting case. So this Idaho cave was home to some remains, a torso, no head or limbs, that was found in 1979. And so it's an interesting story, because they later, I think in the 90s, found some of the limbs. But basically, the body has remained unidentified for 40 years. And the DNA Doe project raised money to basically identify this individual. And so we were the lab that basically took the material and produced a genome sequence from it. And I guess the twist to the story is that we produced a genome sequence, and then these two genealogists, Anthony and Lee Redgrave, which lead our genealogy team now at Othram, they were working with the DNA Doe genealogy group. There's a huge network of volunteers that work super hard to kind of crack these cases. And they discover, interestingly enough, that although the remains were found in 1979, the body belonged to someone that is over 100 years old. So a bootlegger that was himself a criminal and had escaped jail, and it appears that same year eventually succumbed to the fate that that people know about. He got chopped up and thrown in a cave, and it looks like that happened 100 years ago. So took a little bit of a twist, but exciting. So yeah, we produced the genomic sequence from there. And the ability to identify these folks, whether it's this person in the cave or any of these other cases that we've worked, is contingent on data. So we need data. And I believe there was a substantial Mormon tree component to his identification, and that's a value. I mean, there are other scenarios, folks from other areas where there is not as good records on the tree and not as much data points to compare against. And it creates a substantial challenge. And that's actually, I don't know if you're heading in this direction, but that's actually another reason that we put together DNA Solves. Here's an interesting fact. The entirety of GEDmatch, I'm not talking about the consented portion, the entirety of GEDmatch represents less than 5% of people that have taken a test with one of these consumer genetics companies. So that's worth thinking about, because over 95% of the people that get a genetic test, they probably never even heard of GEDmatch, and they probably don't use it. GEDmatch is a really important tool, but it's a power user tool. It's something you use when you're in the advanced stage of building out a tree. You want to make sure you can match to every possible relative. You've exhausted the database that you're at, whether it's 23andMe or Ancestry, and you go to GEDmatch so you can meet folks from other databases, because the databases don't talk to each other. So that's an important thing, because when you opt in people to GEDmatch, and less than 1% of people have actually opted in out of all the people that have ever tested. And when you go to GEDmatch, you've already narrowed down to the power users of genealogy, and then you're asking some subset of them, are you interested in helping solve a crime? Our approach with DNA Solves is not to be a genealogy database, is to basically be a resource where folks can contribute. And so we're really, appealing to the broader market. We're appealing to the 35 million or more folks that have tested worldwide now. And we're asking if any of them, whether they care about genealogy or not, have an interest in identifying, remains like this guy in the cave, or victims or perpetrators of crimes. And so, that I think kind of enlarges our search space for participants. But I think it's really important. I mean, the genealogy is a critical step, and you can't say enough about the hard work that a lot of these genealogists who are volunteering, particularly with DNA Doe, to do the tree building. But for them to do that, they need two things. They need good quality data. That's what the Othram lab specializes in, digitizing remains, no matter how terrible or old they are. And you need good quality, matching reference sets, and that requires representation from everyone. That's kind of another kind of objective of DNA Solves, is to market to the broader audience.
That's fascinating. And I hadn't pieced together, but of course, Idaho has a substantial Mormon population. And for those who aren't steeped in genealogy, the Mormon community in the Church of Latter-day Saints has done an exhaustive job of putting together its own genealogy. I know, people will go to Salt Lake, for example, just to steep themselves in the genealogy archives there. That's cool. I'm reading a book right now. It's an older book called Linked by Barabasi, who's sort of one of the fathers of modern network theory. And he's active today in Boston, has a diagnostics company in addition to his lab. And so I've been thinking a lot about, and he features the sort of 6 degrees of separation, 6 degrees of Kevin Bacon stuff. But I wonder, how many links apart do you think people are going to be in sort of this DNA genealogy world? In other words, what kind of sampling of the population would you actually strive for to be able to connect people to, sort of distant other people?
Yeah, it's a good question. I mean, right now there are kind of the first and second cousin area is very the outlook is really good. When you have a first or second cousin, there's a good chance a genealogist will be able to wrap that up pretty quick. Yeah. Now there's always exceptions, right? Non-paternal events and mistakes in records that can throw even the simplest case into a loop of mystery and investigation. But generally, a first or second cousin is really great. If you have a fifth or a sixth cousin, it's extremely challenging because you're working up a tree very many generations back and then trying to come to the present and figure out who someone is. I think the sweet spot's going to be like around, that inflection point's around like third or fourth cousin. And so I think the goal is like if most folks can be connected to a third or fourth cousin, then I think have a tangible way, a good attempt can be made to make an ID. And so prior to GEDmatch switching to this model of opt-in, they had, just over 1 million profiles. I think it was 1.2 at the time, million profiles. And folks were making a lot of IDs. Now, again, there's a certain bias for who's in GEDmatch, but given that, they were making decent IDs. So I don't know the exact math. I haven't thought about exactly how many you would need. That gives you a data point, The biggest challenge with genealogy is that genealogy isn't, at least this early wave of genealogists were not universally representative of all populations. It's a very predominant Northern European ancestry bias.
I suspect that's true too, though, if you look at people who do consumer DNA kits.
Well, that's where the bias comes from. So
right.
The original value proposition for this consumer testing was ancestry. So folks had spent years using traditional genealogical methods to establish trees, and they were looking for genetics to confirm and rule in or out folks on their tree. And that began with mitochondrial DNA testing and Y testing, and then 23andMe pioneered the idea of using these arrays that assessed, hundreds of thousands of autosomal markers. So all of that was originally in pursuit of ancestry. And from there, kind of took a turn towards traits. And now, as you can see, all the companies are pivoting towards, clinically relevant,
right.
medically important markers. But the original audience was ancestry. And so it just is what it is. Like that appeals to some groups more than to others. But the one cool thing is that, I think medicine is kind of medicine appeals to everybody. And frankly, I think so does fighting crime. I think that largely everyone is interested in, nobody's a big fan of violent crime. And I think everyone wants to do something to help out. Some folks are more apprehensive than others. Some are more driven by civic duty than others, but everyone's, generally interested. And so it may be that some of that bias, shifts as you market, kind of a more broadly appealing topic to folks.
No, that's really interesting. The last week or so, and so here we are in kind of the middle of February, exactly in the middle of February. The first half of February has seen some economics numbers from consumer genomics that suggest that adoption is slowing down. And so, again, for those of you who don't know David's bibliography, in addition to being involved in sort of clinical and research use around whole genome sequencing, he was also a pioneer in the consumer genetics space and the consumer DNA space. So you've been interviewed by a bunch of these outlets running these stories. I think they're mostly based around 23andMe's recent layoffs. Do you want to take a couple minutes and just opine on what you think the patterns we're seeing in consumer DNA are actually saying?
Yeah, it's largely what we've been discussing. So 23andMe and Ancestry both laid off, around 100 folks each. And I don't work for either company. So I think they were kind of vague on the exact reason of who and why they laid off people at the companies. But I think obviously the general consensus is that growth has slowed. So one thing I want to point out is that, people that are investors, playing the markets and all that kind of thing, they're always looking for evidence of a future decline or peak of a product. So it's kind of like when people are laboring over the fine changes in orders made to the Apple iPhone. Apple sells a lot of iPhones, but they're always looking for that indicator as early as possible that perhaps there isn't infinitely growing interest and things are plateauing.
Right.
And they sound the alarms. So that's what's happening here. So I want to caveat by saying that what's being detected in the market is that the slope of growth is no longer as high. It's kind of decreased a little bit. But that does not mean that the era of consumer genomics is over or people aren't ordering tests. I mean, on the contrary, the databases continue to grow substantially. And I think these companies will continue to see continued growth for some time. So what's happening is a slope of growth is decreasing, which is just adjusting the expectations for how fast it'll grow. Right. And it had the most obvious consequence in Illumina, which is why they had to, in their quarterly earnings, that, they're going to push less arrays to the market than they expected. And it makes, companies like 23andMe and Ancestry, I guess, reevaluate who they need and what they're going to do. But I will tell you that I think there's a lot of reasons for why this is happening. And I think the article's done a great great job explaining it. But the biggest signal that I can see here is that, as we discussed, I mean, the early adopters of this market were interested in establishing, confirmation of relationships in family trees. And so genealogy is actually a pretty big hobby, but it's a finite market. It's not huge. It's not what I would call a mainstream endeavor. So what you're seeing is a saturation of a market, which again doesn't mean there isn't plenty of room to grow. It just means that, number one, you're running out of people that are like, super hyped up about doing this. And number two, because of that, the customer acquisition cost is going to start going up. And the other thing to think about is these databases are already pretty large. If you have, let's say, 15 million people in your database, having 16 isn't going to transform your ability to make medical insights, to work with pharmaceutical companies, right? Like you can derive medical value, probably similar value with 15 million as you would 17 or even 18 million. So you have two things at play. One is the databases are pretty large. You can do good things with them. And number two, the customer acquisition cost is probably beginning to creep up a little bit because you're saturating the early adopters to the market. And so I just don't see that those companies are heavily incentivized to grow at all costs. Like they don't need to. So instead, you have this natural saturation of that market. And just like when Apple releases a new phone or someone, releases a new product, as they begin to pivot and roll out more of these kind of health features, I think what will happen is if they roll out things that are valuable and have affinity, then they'll tap a bigger market. And then the same thing happens again. There'll be people that are really excited about this new health product and they'll come in and the customer acquisition costs will get very low. And then at some point they'll saturate that market. And then so this is like the natural wave of like how it's like the life cycle of a product. And so there's a bunch of other things that have been mentioned as well, but I think, and maybe I'm oversimplifying it, but I think this is the primary driver. I think we've seen for a while the growth wasn't going to exponentially increase forever.
Are you interested in, are you putting any effort into the idea of maybe partnering DNA Solves with some of these more established consumer testing companies? Like that might be a way for them to give those data new life, or are the consent modalities fundamentally at odds with each other?
So I would love, obviously, to get as much data as possible, but I think that our plan was to consent people up front. I think reconsenting people is challenging. It's not impossible, but it's definitely a challenge. So I like that in our model, people are consented up front. Like this is why you're coming here. The second line on our website says a database for solving crime. Like it's like extremely obvious why you're here, and I like that. And I think you compromise on your ability to be clear if you're reconsenting other data. The other problem is I think it's just hard to mix. It's hard to mix medicine and law enforcement. That's where all these privacy issues are going to come up. You're contributing your data to an investigation, but is it going to be sold to an insurance company or is someone going to judge you for it? So I can tell you DNA Solves, that's why we made our policy of DNA Solves is that we will do nothing with the data except for human ID. So we don't do medical research. Like we don't do any of these other things.
Right.
And I'm hoping by kind of limiting the scope of use that I can make people more comfortable. We have zero interest. I mean, my company, Othram, we do nothing but human ID. There are other labs that try to do a little bit of everything, a little medicine, a little research, maybe sequence some remains, test some cases. We have an exclusive human identification focus. And I think that the same is true in the reverse. 23andMe and Ancestry have been very, very clear and very vocal that they don't work with law enforcement. Ancestry has resisted requests from law enforcement. And it's for the same reason. I think they're trying to limit the scope of their use so customers don't feel uncomfortable that if they give their data to Ancestry, they'd use it everywhere. So I think in principle, it sounds nice, but it makes the consent complicated. I think it'll hurt the business that 23andMe and Ancestry are trying to build, and it's not really compatible with what we do. So I think you just have to kind of wait passively and you let people know that if they've tested and they want to actively take their data and move it somewhere, they can. But it's just, it would seem really hard. I couldn't even imagine a way that would make sense, to co-promote. You put a banner about Othram on 23andMe's website, and next thing you know, people are wondering if 23andMe is getting into a different business.
Sure.
It doesn't make sense. And 23andMe is obviously a large company doing really great things in the medical space. Like the risk is not worth it to them. The forensics market is very tiny.
Yeah, and as you said, it's probably a different audience. So I'm a little curious, to the extent that you're comfortable talking about how you do business, how does Othram, how does DNA Solves market itself? Like, how do you go find those civic-minded people who want to contribute to this kind of community effort?
It's largely been a grassroots effort. There are core folks that we've met that are interested, and it's kind of spread through word of mouth, Facebook's been a remarkably effective channel for communicating. And, we try to mention DNA solves when we solve a story, and we let people know some of these, even when we don't, there's some cases we worked on where we can't solve them. And so, or they don't get solved right away. And I think by illustrating examples in which we do and do not solve a case, and showing the role that the database played in that, I think that's powerful, because it's one thing to talk about, contributing your data, and it's another to hear a story. That's why I like to highlight, we just talked about this guy in the cave, and there are key things that, increase the odds for success. So I think discussing that. And the reverse is true. There's very poor, for example, representation of Native American data points. And so you can imagine, trying to identify an unidentified Mormon versus a Native American, like it's a different kind of challenge. And it's because of data that's available. So I think highlighting that so people understand. But yeah, I mean, there hasn't been a tremendous marketing campaign. It's largely been word of mouth, people that are interested. A lot of the folks in true crime are just really, really fascinated, and given the option, would love to help kind of join the cause. And again, like we try to highlight it as we discuss work that we perform, either ourselves or on behalf of others, to work these cases.
Is the kind of confidentiality agreements you have to enter into with law enforcement different, the same, more or less complex than if you were doing this in, a clinical setting for some healthcare application?
I guess whichever side you're on, you'll always think it's the harder side. But I think there's some interesting things on the forensic side that are worth mentioning. There's obviously confidentiality, and you need to protect information, but there's also this idea of accountability, right? Chain of custody, knowing who's interacted with the information, knowing what information to pass on, whether it's to a genealogist or someone else, ensuring that you do it in a way that is controlled and documented, so you can, enforce and maintain objectivity, prevent unintentional bias. So that's all things that you would care about in the medical space as well. But there's tremendous scrutiny in forensics around just kind of documentation of who's made contact, even to the extent that, in our lab, you'd want to know all the people that have touched the tube of DNA, which we're going to perform a test. That's a level of scrutiny that I think is a little bit more granular in detail than, for example, what you need in a medical lab. So I think in some ways it's very similar to medicine, obviously protecting personal information. In other ways, there's a lot of documentation, and so it's important. I talked to a DA early on when I got the company started, and he said, he told me, it's great that you're solving cases, but I don't care about solving cases. I care about prosecuting cases. So, and that's kind of stuck with me. Obviously, I care either way. I'd love to solve a case,
right,
regardless, but it's something that stuck with me. It's not enough to simply solve a case. You need to do it in a way that is well documented and in line with what's regulatorily expected, so that that case can be prosecuted if it's a criminal case. Obviously, these projects that involve, DOEs, some of those could be prosecuted, I guess, if you find out there was a crime, but some of them are just going to be regular human IDs. So I think that's kind of my thoughts, having sat on the medical side and then also on this side. Both sides are really rewarding, though. It's super exciting to be able to help someone work through a medical problem, whether it's identifying a rare disease or providing a diagnosis that can make their life better. But at the same time, also exciting on the forensic side to put a name on somebody that essentially has vanished. I mean, and so not everyone that we identify is free of criminal behavior. The guy in the cave, obviously himself was a criminal, but from one perspective, like this person's essentially deleted from society. Right. No one knows what happened to him. He vanished. There's an unidentified body. So there's a certain thrill and kind of, it's like a feel-good vibe that you get from being able to take someone that's essentially been erased from history and give them a story and reestablish them. So I think both are really rewarding endeavors, and both have a lot of overlapping similarity and kind of the seriousness in which you want to handle that information and make sure it's properly compiled and disseminated to others.
And so far, have you seen most of enthusiasm coming from prosecutors, or do you also see folks who are interested in the defense side of things, in sort of getting innocent victims off? I imagine if we did DNA testing on everyone on death row and reevaluated the evidence, the odds are you're going to end up having to turn a quarter to a half of the people loose. How much energy is there for that kind of innocence project?
There's obviously the Innocence Project, and there are countless folks that work just as aggressively as prosecutors work to identify criminals. They work just as hard to make sure that the wrong people don't go to jail. So we're at this point now where technology, DNA testing technology, can really bring some value here. And I think that, look, if someone should be in jail, then put them in jail. And if they shouldn't be in jail, let them out. And if you have a technology such as this advanced DNA testing that allows us to make those decisions a little easier, it's a little more clear to figure out what's going on, I think it would be irresponsible not to employ that kind of testing. So I think it's being used on both sides. I saw a story the other day of someone that was exonerated based on advanced DNA testing. DNA testing, if used properly, is unbiased, right? It'll identify where the DNA came from. And sometimes it'll be the person you think it is, and sometimes it's not. I think it's amazing to be able to make sure that the right people go to jail, and the right folks that are not supposed to be there don't go to jail. Yeah, and I think everyone agrees. Everyone's excited about that, whether they're on the prosecution side or defense side.
Sure.
But there's also a process. There's like a roadmap to get there and do it in a way that's, compliant. As I said, that would like pass the test in court and actually be effective, as opposed to just creating more noise and confusion. So I think everyone wants to do it. The only reason it's not being done every day by everyone is really just that it has to be rolled out and accepted and refined and so on. And I'm a patient person. The same thing happened, if you remember, when NGS kind of penetrated the clinic. People were using other kinds of testing, and as it became possible to fire up a MySeq and start doing these panels, there was it was very slow in the rollout and a lot of validation, a lot of great work done, if you remember, at NIST with Genome in a Bottle and that kind of stuff, to kind of build the benchmarking platform to basically performance test and know that what you're doing is what you think you're doing. And I think that'll roll out as well, just like it did in medicine for forensics. And next thing you know it, just like in medicine, there'll be more sequencers cropping up, and people will be following a vetted and performance tested approach to determine where remains came from. So in the meantime, we've tried to lead that discussion, as we did for Genome in a Bottle. We're trying to lead that discussion and scope a lab. And we have the only forensics lab right now, the only private forensics lab that actually, features a NovaSeq, and as we discussed last time, whole genome sequencing. It's a big risk and a big expense, but we did it because we want to push forward and drive ahead that discussion around standards and regulatory process. We'd like to see this kind of testing secure forensic accreditation. Right now, nobody on earth has forensic accreditation for this kind of testing. All the work gets confirmed using a traditional CODIS test or some other kind of, usually STR-based method to validate and orthogonally confirm anything we discover.
Fantastic. One last question, then, and I'll let you get back to solving crimes. What is the oldest sample you guys have processed and solved? Is it the buffalo cave torso?
Yeah, it's actually interesting. This buffalo torso, I believe it's not the oldest case solved using this kind of autosomal testing. There's a case that was older, but I think it's the oldest one that was solved for law enforcement. I think this is actually the oldest law enforcement case solved by anyone using autosomal testing. But to answer your question, we are doing projects. We are in process with projects right now that are actually older than that, but they're not solved. And so I'd say, if you're asking solved, yeah, this is the oldest project that we've solved. And I believe for law enforcement, it's the oldest project anyone solved. But we're working on some other projects right now that are even older. Once you unlock this technology, there's a multitude of mysteries that stretch back, centuries. And so there's a lot that can be done. And so I'm excited. I hope next time we chat, I'll have a story of an even older case. Every time we talk, I'll try to come up with an older and older case.
Fantastic. Well, David, this is really exciting. I mean, just from the first time we talked and gave our listeners a glimpse inside what Othram is working on, seems you guys have come many, many miles. And congrats on the successes, on the milestones, and I look forward to hearing about the next set.
Okay, well, thanks for having me.
My pleasure.